place a little table there where you could actually plot a few additional points on the graph. I think I did. Guys, let's look at this real quickly. Not too hard. Not be that hard on this. Let's go to the grid. I hope you guys can see that grid. The markers are really messing up here. Here we go. We'll try it. In behavior. Let me get that out of the way right now. I'll have on the quiz tomorrow for you to answer these two questions. First, as x is approaching infinity of this function, written like this, and also find the limit as x is approaching negative infinity of this function. And I think that was being asked on the handout. Guys, how do we find that? It all depends on the first term of this function. Now, those functions not multiplied out. Be careful. Anyone tell me, because the answer is, you need the first term. So without fully expanding, anyone tell me, if this were all multiplied out, what would the first term look like? Jonathan, go for it.
Negative x to the 6.
It is. That's what's going to determine the end behavior. The first term. And he says it's negative x to the 6. I agree with him. Now, let's answer the question. As you make x get large, be careful. As you make x get large, you're replacing x by large numbers, and you're raising those large numbers to the 6th power, which makes them get larger. But there's a prefix of a negative sign up front. So what result might you get with all that in mind? Negative infinity. Here it says x is approaching negative infinity. Well, visualize, you're replacing x by a negative number this time. And you raise it to the 6th power. What happens if you raise a negative number to begin with to the 6th power? It turns into a positive. But I had a prefix of a, what, negative out front? So that final result with all that would be another, if you guys agree, negative infinity. That's true? So my end behavior, there it is, it's described on the handout there. If you want to get that out of the way, let's now look at this real quickly, guys, and let's plot the x-intercept. In other words, you just want to split these up and find real quickly, there's an x-intercept at 0. X is equal to 3, and x is equal to a negative 2. Those are my x-intercepts. Plot those. Here's one at 0. Here's one at 3. This is much easier than rational functions. 3, and also one over here at negative 2. Those are my x-intercepts. So what happens to y-intercept? You go back and replace all these x's by 0 to find the y-intercept. In this case, it's also 0. So I have it on the grid already. Now, in the red over there, the end behavior that says, as this right here, it says go to the end of the graph and make the graph drop down through negative infinity. Something like that. And there's a little curve to it. They're not linear. But there it is. Now, the rest of this should be easy. Now, you got to keep in mind, you may plot a few points. I think I gave a table there to make the graph look a little better. But guys, I now need to consider the cross and the touch. And all that depends on the outside exponents. This one is one that gave me a 0, the x cubed. Since it's odd, I see a 3 there. I know when I reach 0, it should cross. This one, they gave me a 3, and on the outside of 1, for an exponent, odd. So when I get to 3, it should cross. This one, though, on the end, x plus 2 squared has an even. So when I get to negative 2, over here, it should touch. Now, a basic graph with all that in mind, so if you guys will agree. So it's supposed to touch here, bounce back in other words, not cross. How far down it cross? I don't know unless I try a value from that table. That's why I gave you a table to sort of refine it. It's will drop down, gotta come back and pick up this point. What's gonna happen at 0? Odd, it's gonna cross. How high up it goes, I don't know, but it's gonna come back and connect. And at 3, it crosses over again. And there's a basic shape of your graph. Jonathan, tell me, did I, in my table, because I wanted the graph to look a little better, did I have in the table maybe some points to create or plot?
1 and 2.
Yeah.
Negative 1 and 2.
1 and 2?
Negative 1 and 2.
Negative 1, I placed that for a reason. I wanted to actually see how far down this may drop. Just to give some, make it look more refined. And he says 2 is also the table. You just plug in 2 for the x, crunch it out, you get a value, and plug that. That's what that table was for. And guys, basically that's one problem on the quiz tomorrow. You just graph it with the cross, touch, and behavior. Was there anything else being asked besides that? On that practice problem?
The zeros and their multiplication.
Oh, beautiful, zeros and their multiplicities. Here we go. Here we go. 1 0 is 0 itself. Came from this one. Now, look where it came from. It came from here. What would you say? Because the degree degree altogether is a 6. I should have 6 zeros if I were asked to find them. What do you think it tells me about 0 itself that came from this first factor? Now, see an exponent of a 3. Might this tell me this thing has a multiplicity of 3? It's like 0, 0, 0. So this is the multiplicity of 3. Next one, the 3, which is another 0, it came from this factor. On the outside was 1. So it says it has a multiplicity of 1. It shows up once. And finally, when I reach this factor, which gave me a -2 for a 0, x-intercept, on the outside there was a 2, which indicates this one has a multiplicity of 2. And that's what I went for those. Make sense? Can we do one of these tomorrow? We've talked about this so much. And I think basically, was that all I was asking for on that particular page? I think it was. That was it. You guys should have one of these tomorrow. Just like this. Set up just like this. Now ask your questions now. Are we okay with this? And of course the shape should look something like this. Yes, no? Okay. We've done so many of these. Multiplicities, and behavior, the graph. You have a graph, something like this. I don't see any questions there. If you flip that over, I'll go ahead.
What's the point of the -1 and 2?
What's that now?
The chart you have?
All I did in that table, here's what I did. I did this in the table. I asked you in the table, here we go, good question here. He says, Professor, why did you place a -1 and a 2? What do you want to do? I want you to find the y, because I like to know at -1 on this graph, how far might it drop down? Be more, it looks better. I just barely have mine dropping down, but it may drop down further. So you gotta find this number by merely going back and replace all those x's by -1. I mean, by the way, has anyone had time to replace all those x's by -1?
Yeah, -4.
Is it -4?
That's what I got.
You got a -4.
And then the 2 was like 128.
And this is 4?
No.
No.
No, it's not negative. Negative.
-4?
-1.
Oh, the first one's still -1?
Negative.
No, they go
I was -1.
Let me put it in myself.
Okay.
-1, that's a -4. And over here, -1 plus 2, I think it's 1 squared, still 1. I did mine quickly. Negative sign to begin with. Now replace x by -1. -1 cubed is -1. -1 subtract 3, -4. -1 plus 2, 1. And all that together is a -4, isn't it? See, a negative. That was given to him. A negative, a negative. Is that a -4?
Yes.
The 2, negative, 8, -1, maybe down here something big, what was it, 16? You go through and replace those x's by 2 and crunch out the math. Now I'm looking at mine, it is. Big numbers, positive, 8 times 16, that's what, 128? And you say, what, Professor, why'd you do that? Because now I know that this one, oh, this one's reasonable then. This one drops down maybe down to a -4. This one goes much higher. That's what I wanted to see. Just the effect of that. This one's pretty reasonable right now. Of course, you don't go way up there at 128. At least it's higher than this one here. Or that's not what is high, that's not drop down low. That's what I wanted that table. Just create some numbers. Was there anything else on that? I don't think there was. So right there is 5 points of the 10 points. Yes?
This might not matter,
Go
but
ahead, go.
is, because, an exponent, leading exponent is 6, wouldn't there be 5 turning points normally?
Ah, beautiful, 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 beautiful. Now she said, and she says, Professor, when you graph one of these polynomial functions and you count the number of turning points, that's like the local max, local min. I have one here, and one here. So how many turning points do I actually have in terms of this? It's like asking for local max, local min. I have altogether, what, 3? The rule was, on one of those handouts I gave you, at most, you would have your degree subtract 1, n minus 1. And my degree here is 6, the 6 minus 1, she says, that, Professor, that's 5. We got only 3. Whether the rule says at most you can have 5. Okay, good question though. Just looking at the number of turning points. Okay, anything else, guys, on this one? Everyone should get 5 points in this. No excuse. Go ahead. Yes.
Should we write the 2 points on the graph?
Should we, on the graph,
Should we write the 2 points on the graph?
oh, these 2 points.
Yeah.
Yeah, I just want you, yes, you should. So out -1 down 4, you'll show me on the grid how you drop down to -4. And here you'll just go way up and mark this as 128.
But we don't know the maximum and the minimum.
Yeah, because there'll be a local min, there's gonna be a local max. Now, you're not gonna be able to find exactly where they are until you do calculus. I just had you to plot these to get an idea how far down it drops and how far up it goes. You're not gonna be able to find the max and min unless you've had some calculus. You won't be able to find the true max and the true min. Mr. Parker found them, but we can't find them. Rita could find them. But for me, just a graph. Now, what's the last problem? The other 5 points? Guys, what did I do on the back of that? Did I do anything at all on the back? Is there something on the back of the handout?
There's 2 example problems.
Was it still talking about polynomial functions?
Yes.
Now, that's just for you to look at and get ready. Guys, one here, and then the other, now this may take a little time, the last one, is to find the complex zeros. That's your quiz tomorrow. I don't get 10 out of 10. Now, this one could be the issue. I don't think this one's gonna be the issue. I think every student will get a nice, smooth graph marked for me, like I did here. That'll be the easy part, the graph itself. Part 2, though, now I'll give you a function and ask you to find the complex zeros. Now that is where Miriam was doing her homework. She says, Professor, these things can get crazy, because this is where you list the P over Q, like we were doing yesterday, and you gotta be patient. You start checking, hoping to get a 0. That's where I don't know Adrian. I think it was Adrian one day. I think it was him. Came just out of the blue. He says, Professor, check 1/2. We had all these string of numbers to check. He says, check 1/2. And it worked. Okay, so watch out for that. That's the type that you're going to have for part 2 of the quiz. I'll give you one. It's not going to be too crazy. You got to use P over Q. You got to go through and start checking. And also, you may get some imaginaries or complex in there also. But the big thing is, you got to choose a number of those 12 or 16 possibilities and test. And if you find one, you're gonna be pretty much on your way to the answers. Wow, yes,
Do we have to list the P and Q?
beautiful. You do this on scratch paper. Because I just left a little limited space on the quiz itself. So on scratch paper is where you'll start testing. I don't wanna see all those tests. Until you find one to work. And you bring back to your quiz and show me the one that worked. So, Jonathan, your question, you say, oh, Professor, I tested on the scratch paper, nothing works, and finally I found this to work. I say, Jonathan, you did? Yeah, give me a 0 over here. That's the one I wanna see on the test, the quiz itself.
And I know all the P's and Q's, the plus and minus, all that stuff.
No, you're going to do that on scratch paper. I'm not concerned about all those. I'm just concerned about what works. Okay? Now, I'm not gonna go crazy on you. I'm not gonna go crazy on you on this quiz. I'm not gonna put an X to the 10th on here where you find 10 zeros. Or an X to the 8th, we've got to find 8 zeros. I'm not doing that. If I'm not mistaken, I think it's like an X cubed. Maybe X to the 4th on your quiz. Now, take a little time just to find those. It's small degree, yeah.
Do you want us to list out all of the possibilities, like?
Now, that's what he's asking. No, you're going to do it on scratch paper. You want to list all? Yeah.
Not the finding with the zero, but I mean like all of it, so like 2, positive, negative 2.
Oh, I got you. I'm gonna let you do all that on your scratch paper. So when you start listing, here, plus minus 1, plus minus 2, plus minus 3, plus minus 4, you're gonna do that on scratch paper. Soon as now, when you start testing, that's when you're gonna bring it back to my quiz and show me what worked. I just wanna see what works. Okay? Good question there. Absolutely, yeah.
Just to clarify, what you're basically saying is you don't wanna see the list of, the part where we list the factors being only.
Oh, no. She's talking about the P over Q. You can do that on scratch paper.
Okay.
But if you find the numbers that work, like this, then the answer will ask you to take them back and tell me now, where am I? Oh, in factored form, what does your function look like? So let's say -2 worked. You're gonna say, Professor, if you want it in factored form, x plus 2 must be a factor. Did we not discuss that? Of course we did. So after you find these that work by using synthetic, then you know how to take them back. So if you say, Professor, I checked another number down here, oh, you did? Yeah, I checked 1. And it worked? Yes, I got a 0. That means my factor here would be x minus 1. Yes? No? So you can put it in factored form. Adrian, that's what I'm talking about. We've done that in class. Miriam.
Okay, say you gave us like a cubic, and then you found a factor that worked, and then you see this polynomial,
You can factor that.
you factor that?
Yes, if it'll factor,
Yeah.
factor, and it'll save you from testing.
Okay, great.
Let's say you check 1, like she said, you check 1, Professor, I lucked out, I checked 1, my first number I checked worked. And it's a cubic, you're looking for 3 zeros, now you're down to 2, you're down to a quadratic, you can find the other 2 by using a quadratic formula or factoring, and no additional testing. We've done some of this in class. Haven't we? Of course. Okay, guys, geez, let me think now, I don't want to mislead you. Should I give you guys a copy of the quiz? See if it's okay? Yeah. So this, and a graph. Think about anything else, I don't want to mislead you. I think basically that's it. If you have those 2 concepts and see me at 2 o'clock, tomorrow, that would help also to practice more. Nima, what was that question?
Yes, excuse me, I'm sorry, my question. When we found one of the roots by rational zeros theory and weight, can we, for continuous solving, can we put x minus c and c like the roots divided by the function and continue solving?
You mean, are you talking me after you find one, maybe
Yes.
you're left with something that could factor and not, no additional testing?
Yes,
Yeah, that's
exactly.
what Miriam's talking about. You could. You could. Absolutely. Wow. Okay, I should get lots of nice scores there. Guys, I think that, what else is on the back there? Because I don't want to leave that, because I'm going to start reading chapter 40. I don't want to leave too fast. Oh my goodness, oh my goodness, my goodness. The last part of the, on the other side, there's a graph. Woo! Lord, how do you this? I give you a graph. The graph's already been done for you. And I ask you to look at the graph and name the function it came from. Okay? Now, here we go. P of x is equal to. I would suggest that you go ahead and put a place here for your coefficient before you start writing the factors. Because I might have given you some information on down there where you can find that particular coefficient. So I'm going to have an A to represent that coefficient, and I may be able to find it. Now, can anyone tell me, based on, I don't have the graph right in front of me, the x-intercept and whether it crosses there or does it touch, and I can write the factors. Who would like to go from left to right and tell me the, Jonathan, go for it.
All right. X plus 3,
What?
multiplicity 2,
X plus 3,
multiplicity 2, and then x plus 1. And then x minus 2, multiplicity 2. And then x minus 4.
like that, like that. You guys agree with it? Based on your x-intercept and whether it touches or crosses? Because if it touches, you're supposed to use an even exponent. If it crosses, you're supposed to use an odd. Are those correct? Now, would I count it wrong if a student says, Professor, I know even and odd. Could I have put a 4 here? You put a 2. That 4 is even. I couldn't count it wrong. So I prefer, though, the lowest even and the lowest odd. You gave me an odd over here, I should be a 1. If I saw a 5, I couldn't count wrong. But I want the lowest. Looks better with the lowest, even and odd replacements.
That was the question.
That was the question. Okay. Now, did I, Jonathan, to close this down, geez, did I also throw in for some reason a point on that graph and name it for you?
Yes.
Like what were the coordinates?
1 and negative 2.
That is on there for a reason. Anyone tell me why would I throw that point in there also? Why? Angry. You're gonna be able now to find the A. The coefficient out front. Is that coefficient out front 4, negative 2, 1/2? I don't know yet. Now with this though, it says go back to your function and do this. This is negative 2, got A, and replacing all the x's with 1. We're doing mathematics. I don't want to mess up your arithmetic here. You step back and look at it, make sure that looks good. Yeah, that looks good. Don't mess up on the math. Negative 2, A, this is 16, 4 squared. This is 2, 1 plus 1. This is a negative 1 squared, 1, and it looks like a negative 3 there, so if you guys agree. Just go and replace it. We go down here to finish it up. Negative 2 is equal to, now this product, guys, all that together is 16 times 2, that's 32 times a negative 3. Big number, I think it's a negative 96. A. Yes or no? I hope I didn't make a mistake. Now how can I get A itself? How can I solve for A? Divide through by what? Negative 96. Negative 96. I hope we don't have an arithmetic mistake in there somewhere. It's going to be a positive answer. I'm going to reduce it down to 1/48. Yes or no? And for your final answer, that goes right here. That's your coefficient on this particular function. Now you're complete. Make sense? That's what to expect, those types of problems on the quiz tomorrow. Okay. Now, check the time here. Wow, wow, wow. Guys, I checked the syllabus and the schedule, because I gotta keep up with all this myself. Oh, here we go. Does the syllabus, if you look back for the homework, you say today is Tuesday, what is today's date, July the 8th? Are we pretty close to where we should be? You guys are doing your homework, are we pretty close? Got that, guys? Yes, we are. We're pretty close on homework, when you check your homework schedule, are we pretty close to it? Miriam, do you have yours handy? Just fill the schedule for homework and tell me what sections did I, at the time I created the syllabus back last year, what sections was I supposed to be covering today?
Today is July 8th, we didn't have a homework for today.
Okay.
Yesterday was 4.1 and 4.2.
That's what I wanted, yeah, okay. 4.1, 4.2, so we're almost right where we should be, right? Okay, now. In fact, this is 4.1, 4.2. So we're on schedule. Yeah, we're on schedule, aren't we? Based on the syllabus? Yeah. Serena, Mr. Park, I hate to bother you guys because I know you're busy creating these